With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So the question says, in a YDSE, that means young double slit experiment, there is a parallel beam of light of wavelength 6000 angstrom incident on slits at an angle of incidence 30 degree. A and B are two thin transparent film, each of refractive index 1.5. Thickness of A is 20.4 micrometer. Light coming through A and B have intensity I and 4I respectively. On the screen, intensity at point O, which is symmetric relative to the slit, is 3I. The central maxima is above O. Number 1. What is the maximum thickness of B? To do so, assuming thickness of B to be that found in part 1, answer the following parts. Find the fringe width, maximum intensity and minimum intensity on screen, distance of nearest minima from O, intensity of 5 intensity at 5 cm on either side of O. Let us start by first making the diagrams and writing the information which is given to us in the question. So the information which is given to us is that the lambda is 6000 angstrom, the refractive index mu is 1.5, the thickness of the slit A, which is this, is 20.4 micrometer. IA, intensity of light at point A or slit A, is given as I, and intensity at slit B is given 4I. So we have drawn the diagram here, and as you can see that the incident angle is 30. D dash, which is the initial path difference, can be written as phi dash, which is the initial phase difference, can be written as path difference times k, and the initial path difference d dash can be written as d cos 60 or d sin 30, which can be calculated and taken out as d by 2. So now we can write that the intensity of these two incident rays are written as I1 plus I2 plus 2 root I1 I2 cos phi. So for a general Y, we can write the delta x as d by 2 plus AP minus T1, which is the thickness of the slit A, plus mu naught T1 minus PB minus T2 plus mu naught T2. Now if we calculate this, we will find that we have arrived to 10 to the power minus 3 upon 2 plus 10.2 upon 10 to the power 6 minus T2 by 2. So this is what we get after solving this. We can write the value of D as 10 to the power minus 3, which is given here 0.1 mm. Sorry, this will be 10 to the power minus 4. So further we will do things as follows. Next, the information which is given to us is that the intensity at point O, which is symmetric relative to the slit, is 3I. So this we can write as 3I is equal to 5I plus 4I cos phi. And now when we solve, we get cos phi is equals to minus half. That means this is the smallest angle. That means phi is the smallest angle, and phi comes out to be 120 degree, which can be written as 2 pi upon 3. Now we can write phi as kx, and when we solve it for for x, we get the value of x as lambda by 3, which comes out as 2 into 10 to the power minus 7. Now we can substitute the value of x here and find T2. So when we solve the equation, we get the value of T2 as 120 micrometer. So the thickness of the slit B is 120 micrometer. And now further going with the question, we can find the fringe width, which has a formula lambda d upon small d, which is 6 into 10 to the power minus 7 into distance, is 1 meter, and here 10 to the power minus 4. So this comes out to be 6 into 10 to the power minus 3, which is equal to beta, and we can find the maximum intensity as root I1 plus root I2 squared, which is equals to 9I on solving, and minimum intensity, which is equal to root I1 minus root I2 whole square, which comes out to be I. So this is how we solve the question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.